So yes, thanks very much for the invite, and to all the other speakers so far. This has been an absolutely fantastic whatever day into third, I guess. So far, I've really been enjoying it. So yeah, what am I going to talk to you about today? It's a bit funny for me to be at a meeting on the Mendelians on the back of, or on the strength of, essentially having published a book about the non-Mendelians. So you keep hearing sort of oblique references, right, to this competing trend, this non-Mendelian trend that was alive in the life sciences and the study of inheritance and evolution from sort of 1880 to 1910 or so, the biometrical school. If you want to know, the page down doesn't work either at this point. Please. No, really? Please? There we go. If you want to know a lot more about that than you ever wanted to know, check out this new book. So this just came out this year. Let me give you the 5-second version of what the book is about, and then I'll kind of make sense of why I'm here and what I want to talk about the early Mendelians. So the book sort of starts from this interesting kind of question, or at least I've always thought it was interesting. When we read Darwin's Origin of Species, right, most of the book seems still for today surprisingly up to date, surprisingly current, surprisingly readable, surprisingly interesting for a book that is now 200 years old, right? I mean, you might, there's a lot of other books that were written in 1859 in the life sciences that are like not exciting anymore, right? And Darwin is. Well, part of what that does, though, is it draws our attention to the bits of the origin that don't feel modern at all anymore. And I think one way to draw out a piece of that is to compare to just a few years later. So by the 1930s, here's one of Sewell Wright's first adaptive landscapes. And we've gone from a sort of individualized view of adaptation with no math at all. Darwin goes 400 pages with one abstract phylogenetic tree and no formulas, to this wild thing that is abstracted statistical populations moving around on a hypothetical landscape of fitness values, right? That's a big change that happens really quick. And so that's essentially the 5-second, what's the book about? It's trying to make sense of this move. So we had this shift to a statistical theory of evolution that lets us understand selection at the population level. And here comes Mendel now in sideways, right? As of 1900, almost everyone, and I'll come back to this, but almost everyone immediately realizes we've got to make sense of Mendelian transmission as part of the story, right? Even the, as I'll say in a moment, even the committed non-Mendelians were still committed in some sense, with a few exceptions, to the idea that, look, Mendelian transmission happens. It's out there in the world. We have to be able to take account of it at least in some way or another in our biological theorizing. So what do I want to do today? I'm going to do the thing that about 2/3 of the historical talks so far in the conference have done, which is let me tell you the classic textbook history that you often hear about what happens in this period, and then let me show you why everything is more complicated than you thought it was. That you're probably all really used to that after the talks that we've had so far. My classic history, though, is going to be a little bit different because I want to tell you the classic story of what happens to natural selection. So I forced selection into the title here, which isn't on the program, very deliberately. So I want to tell you a slightly different, not just the inheritance story, but the selection story, with the contours of which are not quite exactly the same. They're not quite exactly the same in the following sense. So here's a schematic that's maybe less helpful than me just telling you stuff, but I don't know, pictures and arrows are fun. We start with Darwin, right? We start with a Darwinian view of natural selection. Over the course of the period between 1880 and 1930, this sort of bifurcates into these two traditions, right? And on the one hand, we have this non-Mendelians who take themselves to be sort of the real Darwinian disciples, if you will, keeping a gradualist, but also very statistically focused picture of natural selection and evolution. This is people like Pearson and Weldon. And then we have the Mendelians, who very explicitly, at least especially people like Bateson, are taking themselves to be non-Darwinian, in some sense not that interested in natural selection, really interested in thinking about how things like an instantaneous change from use my new favorite example, from a yellow tiger to a white tiger, could give you the kind of rapid speciation generating transformation that you would really need to create species in the wild. And this was a sort of radically new way of thinking about a non-gradualist understanding of selective change. What's interesting about this, though, right, is that means that according to this classic story, when we're talking about this natural selection-based perspective, right, Mendel is sort of bad news in a funny and unexpected, in a funny way that's sort of unexpected for us from a contemporary perspective, right? Why is that? Well, in part, it's because Mendel showing up, at least as this classic tale has it, mires us in this fight about gradualism versus saltationism. How fast does evolution go? Should we use math or statistics or not to describe evolutionary theory? Should we just keep being old-fashioned physiologists, maybe with a little bit of Mendel sprinkled in? And this failing that we heard a bit about yesterday as well from Uta, I believe, to integrate statistics and chance into a Mendelian perspective, because statistics was sort of the tool of the non-Mendelian. So you heard a bit about this idea that there was this sort of warfare in this time period. And the way that expresses itself in this stock history, right, is, okay, this tradition bifurcated into Mendelians and non-Mendelians, but don't read any of that literature and don't bother thinking about it anyway, because they were all so busy fighting with each other that what matters in the end, again, according to this classic history, is that people like Fisher and Wright and the early architects of the modern synthesis sort of show up and sift through the wreckage. They pick out the good parts of Mendel, they pick out the good parts of Darwin, they ignore all of this angry fighting from the 1880s to the 1930s, and they kind of rebuild a new picture of evolution on a Mendelian basis. And the 5-second version of like what I want to do today is to argue against this kind of caricature of what's going on. You do see it described pretty explicitly some in the secondary literature. Bill Provine's classic book on the origins of theoretical population genetics, right, says sort of wistfully about a really interesting figure that I'm not going to talk about today, George I.D. Ewell, that he followed the approach of population genetics, but conflicts among his contemporaries prevented its development at this time. This was in 1902 that he was doing sort of proto-synthetic evolutionary work. Or Sturtevant, I mean, Sturtevant, obviously very, very well-known population geneticist. This is a sort of actor's history of what happened in the early years of PopGen. Says that the personal quarrel between Bateson and Weldon certainly delayed the utilization of the powerful methods of statistics in much of genetics. So you get this like air of wistful regret, right? If only we had been smart enough to realize that we could just all get along and we hadn't been fighting, then we could have advanced the development of biology by 40 years or something. And so my take-home message is it's all more complicated and interesting than that. The period from 1880 to 1930 is really cool, really messy. The early, both Mendelians and non-Mendelians are all in some sense working in the same direction with different methods and different tools, but there is this sort of kind of vibe in the air that I'm going to try to reconstruct for you that really does feel like a lot of these people are pulling in the same direction. And so it's much less about this kind of useless, wasteful fighting than the classic presentation. The classic presentation would have it. So yeah, let me give you a 5-second intro, 2-minute intro to this non-Mendelian tradition, which we've been hearing bits and bots about, but you haven't really gotten in detail yet. So if you don't know what the biometricians are doing, who are the biometricians, what are they up to, this might help a little bit for you to see what that's about. You already saw this picture on the cover of Greg Raddick's upcoming book, which let me also urge you to go buy. So now you've had multiple people whatever, stumping for Greg's book in his absence. It's going to be amazing. This is an image from Weldon's 1902 paper. This is Weldon attempting to cast a little bit of doubt on Mendel's initial results, right? Just take the top row here, and Weldon's point is essentially, yeah, sure, the left-hand thing looks like green peas and the right-hand thing looks like yellow peas, but good luck categorizing the stuff that comes across the center. If you're going to categorize it, your categorization is probably going to be theoretically motivated. Reconstructing what he did, now I'm thinking about the genetics talk from yesterday, reconstructing what Weldon did in terms of tracking down varietals of peas out of seed catalogs is probably extremely interesting. This paper is really fun. Yeah, I could give you could put me and Greg on this stage and Yafeng as well, and we could talk about this picture for like 6 hours, but let me not do that. But even after casting doubt on the Mendelian results, even being one of the card-carrying non-Mendelians, even Weldon comes around in 1904, 1905, before his untimely death from pneumonia in 1906. Don't work yourself to death, junior scholars in the room. He died at 36. As a 37-year-old junior faculty member, this is like, you know, yeah, take vacations and stuff. It's good. Take care of yourself. He, even though by the end of his life, is thinking about how can we tell a theory that gives me non-Mendelian stuff, like the stuff I'm interested in, but also Mendelian transmission as a special case. And he goes back to Galton. I don't need to get into the details of the theory that he's trying to do, but this quote here is just to show you he's thinking about integrating the non-Mendelian picture with the Mendelian picture in a really deep and complex way before he dies. So even the non-Mendelians are becoming Mendelians. That's not true for Carl Pearson. And if you're interested in Pearson, you can ask me in the Q&A, but that's a separate issue. Then there's the Mendelians, and so that's why we're here. I want to talk a bit about this. I was actually very excited to get the email from George, because Darwin once said in a letter to a correspondent that his little bit of it's like a third of a chapter on embryology was his pet bit in his book, In the Origin of Species, there near the end. And I sort of feel like the chapter that I'm talking about here today is like my pet bit in my book that I didn't think anyone would care about or find interesting. And then I get this email from George that's like, that chapter was really cool. Like, yes, someone cared about that chapter. So let me tell you about this fun chapter. How did we get this idea of a kind of deadly fight, a sort of complete lack of interest in these kinds of methods, the sort of visceral hatred going on between these two camps? And I mean, I think it's not that this doesn't happen at all. Here's this photo of William Bateson that we keep seeing. Bateson, yeah, absolutely. Bateson sees no use in, for that matter, in general, I don't have a quote, I don't have the quote here for this, for natural selection really as a whole. Bateson actually says at one point in one of his books, look, we're thinking about evolution. I'm paraphrasing pretty heavily here, but I promise this is a real quote. We care about evolution, and we're going to keep the evolution problem in the back of our minds while we do work on genetics. But we simply don't understand enough about genetics and about genetic physiology to be able to confidently make interventions into natural selection or evolutionary theory now. It would be better for all of us early geneticists if we just took the evolution stuff and set it aside for 20 or 30 years, and we'll come back to it when we know more about what's really going on. And he doesn't exactly hide his scorn for the non-Mendelian camp, right? Of the so-called investigations of heredity pursued by extensions of Galton's non-analytical method and promoted by Professor Pearson in the English Biometrical School, it is now scarcely necessary to speak. So Weldon is now three years dead in the ground, so he can just say, look, it's all dead and gone. And to those who hereafter may study this episode in the history of biological science, it will appear inexplicable that work so unsound in construction should have been respectfully received by the scientific world. I really hope no one writes this about me after I'm dead. At least just don't write it. It's fine if you don't write anything, but don't write this about me, please. So partly there's just a deep personal conflict here. Partly Bateson doesn't care about mathematics. So here's a letter from Leonard Darwin to R.A. Fisher from 1928, where he basically says he's talked to Galton about this. And part of the issue in looking at this period is that Pearson can understand Bateson's papers, but Bateson can't hack the math. So he doesn't know what's going on with the statistics in the non-Mendelians. So yeah, sure, there are parts of the life sciences in this period where there is a whatever red in tooth and claw war of all against all. I don't want to disagree with that. That's absolutely the case. But there are also parts where things look different. And I think it's really interesting to cast a slightly wider net. If you want me to give you a sort of historiographic thesis that sits underneath this chapter, why would you tell the history the way that I'm telling this history? In part, it is that we've been too focused on these big angry names. We know who Bateson and Pearson are. We spend a lot of time looking at how, and also they're just mean people, sort of fundamentally. We spend a lot of time looking at them shouting at one another in their books. If we slow down, step back, and take a broader view of what's going on in the literature, in the biological community as a whole, we see a lot more and a lot more variety. So I want to talk a little bit about two things. The first thing I want to do is I want to underline a series of sort of piecemeal advances. So ways in which, sure, these weren't sort of all the bits of the package that I mentioned about a population level theory of natural selection that's both Mendelian but also phrased statistically. It's fair enough that you don't get a complete version of that theory until R.A. Fisher in 1930. But you do get people who pick up little bits of this and run with it. So I'm actually super excited. I don't have to say much more about Johansson because we've already seen some Johansson. We're also going to see in the next talk some similar stuff on statistics coming out of the early Mendelians for data analysis. So I can kind of skip the first point with aid from the rest of the program. I will show you examples of these last three. So we have some people who work on theories of mathematical inheritance, even though they don't have statistics to sort of back them up. And there's this, especially small American school dedicated to some of the most painful long-form equation grinding that I've ever seen in the biological literature. You've also got this very weird table estimating the speed of selection. I'll talk about this in just a second in the back of one of Reginald Punnett's books, which is very odd because he also deeply hates the statistical method and yet is using it in the appendix to one of his books, although it's actually Harry in 2 minutes. People who are pursuing a pretty well fleshed out of statistical, but not talking about it in terms of natural selection. I'll come back to that as well in just a second. So what's this American school of sort of mathematical inheritance, but without statistics? Well, you've got people who sort of realize that the probabilities that you get from various kinds of breeding schemes, and this is to some extent inspired by Mendel, can be ground out longhand with recurrence equations. So if you've ever spent a long time doing, like, for your sequences in series class in calculus, right, repeating a recurrence equation to get to a steady state, there are something like 100. This is one page of, I think, a 38-page article. There are hundreds of pages that look like this. We start with a certain kind of distribution of characters, and then we keep applying the Mendelian transmission recurrence equations generation by generation by generation, and we see if we get to a steady state. And so you'll see here, like, it took 147 generations for the ratio of hybrids to stabilize in to converge, essentially, as we would say it now in the population. This would be annoying to do with a computer. I cannot imagine how unbearably annoying it was to do longhand in 1916. But this is, right, a mathematical approach to understanding statistics. It just doesn't have the methods, or to understanding inheritance. It just doesn't have the methods of statistics that we would recognize today. Here's this weird table from the back of Punnett's book on mimicry in butterflies. This table is dropped in. He never talks about it. He makes no reference to it in the main text, but it's printed in the back for some reason. It is an estimation of the speed of natural selection. created by a Cambridge mathematician named Harry Norton. And I don't even know why it's in the book. It's really interesting. It takes a couple of ratios of a couple of initial population ratios and thinks about what happens if a new variety is introduced with a certain degree of selective advantage. So how many generations would it take if we had a population with a certain kind of structure and we introduced a new variety that was I don't know, 27% more selectively advantageous, and the population was 90% formed of the old, and then you crunch out how many generations it takes for the new variety to take over. So it's a question of how fast natural selection could act in certain kinds of structured populations. Very cool, very interesting. As far as I know, though, nobody really takes this and runs with it. It's a very weird kind of stillborn table in Appendix 2 of a book about butterflies. Weird. And then lastly, you have, and we've heard some discussion of East's work already in the conference, right? You have people who are developing statistical theories of inheritance. We're trying to figure out how we can use Mendelian transmission to get back things that look more like normally or continuously distributed characters. And that's happening as early as Nielsen Ayla's work in 1907, if my memory doesn't fail me. And it's a sort of rediscovery and popularization. There's rediscovery again by people like Edward East in the early 1910s. Again, there's no natural selection in here, but we do start to see picking back up, pushing for this same general idea. The last thing that I want to do is I want to run briefly through the textbooks because I think this is also really interesting. So I did a quick survey of what would people have been reading? What would you have been learning from if you'd been a student in the 1900s or 19-teens? And you'd have been reading books like Robert Keith Locke's Recent Progress on the Study of Variation, Heredity, and Evolution, or J.R. Arthur Thompson's Heredity, or E.S. Goodrich's The Evolution of Living Organisms. That's the kind of books that you would have been taught out of. And what do you find when you go look in those books? What you find is not this idea that there's some kind of massive gulf between Mendelians and non-Mendelians, that we're engaged in a holy war, that we're all fighting it out. What you find is people basically saying, look, there's these two really interesting ways to study evolving systems. There's this kind of weird statistics-y thing that some people who are good at statistics do, and there's this weird Mendel-y thing that some people who are really good at crossing plants do for a living. And they both seem to tell us really interesting things about what's going on in evolving systems in an evolutionary context. We don't really know how to bring them together yet. But there's no indication of a sort of massive conflict between these two groups. There is a genuine desire in all three of those textbooks. All three of those authors say, we really need to figure out how we can write a theory down that will bring all this stuff together, because they all seem right and they all seem smart and they all seem important, but we don't know how to do that yet. And that's just not what you would expect at all on this classic history of what we normally tell happens in this period, that there's this kind of wasteland after the Mendelians who trounced the non-Mendelians. That's just really not what you see when you look at the biology that you would have learned as a school kid and the biology that R.A. Fisher did learn as a school kid. So Anthony Edwards has found the copy of Robert Locke's textbook in the Cambridge Library where Fisher would have studied it, and there's a graph in there that has an annotation on one of the axes in Fisher's weird spidery handwriting that's immediately recognizable. And so we know that, in fact, Fisher was reading exactly those textbooks. So again, to push back on the classic thumbnail history a little bit, the synthesis wasn't invented out of thin air either, right? You're talking about people who were deeply embedded in their biological context, who knew the state of the current literature, and who also shared this idea that we can sort of push to bring together these disparate traditions. And so with that, that's all I've got for now. I'm happy to take questions. The book has a website, so you can go check it out there if you're interested. Thanks.